When considering restoration, there are four main approaches. The first is no action. Now, I know that sounds kind of silly. Um, the goal is to restore a site. Why would we do nothing? But restoration might be really expensive. There might be previous attempts that haven't worked. But sometimes the ecosystem will recover all on its own. And so, why should we spend money to restore something if the ecosystem is going to go through succession or certain processes that get it where we want to go without us needing to do anything? And this is called passive restoration. And so this is really the best thing to do if your ecosystem will recover in a short time period. The next thing is rehabilitation. A degraded ecosystem is replaced with a different but productive ecosystem. So this isn't true restoration because you're not getting it back to what it was previously. In this case, like a degraded forest might be replaced with a tree plantation or a productive pasture. This might be done if you want to get some use out of the area, but it's just not going to be possible to completely restore it. Partial restoration is when you improve ecosystem function, but it doesn't make it all the way back to what it was prior to being degraded. And complete restoration is probably what most of you would have thought of in the first place, which is restoring to the original species composition and structure along with all the ecosystem function and services. So this means that we've made the ecosystem work exactly the same as either a reference site or sometime in the past that we deem as being the ideal goal. This graph shows kind of the trajectory along this and how we can move to change the ecosystem with these different options. So this circle, the white circle, represents our degraded ecosystem. And we have the four possible options that we just talked about. And we see ecosystem function here on the y-axis. So as this circle moves up, then we're getting more ecosystem function. We might get more plant biomass, more nutrients in the system. That ecosystem is just functioning better. A degraded ecosystem is going to have low ecosystem function, but also low structure. So low numbers of species and low ecosystem complexity. As we move this way, we get higher numbers of species, more biodiversity, and increased ecosystem complexity. So one thing we could do is nothing. Now, depending on the ecosystem, it could continue to deteriorate. And if that's the case, we may really want to take some action to try and help it recover. If we don't do anything, it might continue on its own without us doing anything up this trajectory towards the original ecosystem with no action. So if it starts doing this on its own relatively rapidly, then you probably want to keep doing nothing because that's an inexpensive way for it to restore itself. If it starts going this way, you may want to do something about it if you want some value to this piece of land. Rehabilitation we talked about is to restore some kind of ecosystem function, but it's not going to be the same as the original ecosystem. So it has two categories here where you can rehabilitate it, replacing a few species, or potentially replacing many of the species, just not all of them. Partial restoration moves you along this line where you get increased ecosystem function and increased ecosystem structure, but you stop before you get all the way to the original ecosystem, possibly because it's too expensive or maybe it's going to take a really long time. An example might be like an old growth redwood forest. It might take 1,000 years to get there, but you can send it in that direction a little bit. And complete restoration would get you all the way back to this point which represents what the original ecosystem was. So complete restoration, the first step is to determine and mitigate the source of ecological degradation. Then there's site modification, so you deal with the abiotic factors. Then you reintroduce species that won't come back on their own. You might need to do some maintenance, so that might be continuing to add plants or continuing to do different things to keep moving it towards that historic ecosystem that was there. So this is kind of a graph showing that idea. So we have ecosystem attribute on the y-axis going from non-functional to fully functional. So we basically want to move the ecosystem all the way up to here, and we want to change the ecosystem state from degraded to intact. And these stair steps represent different actions that we can make. So the first thing is this site is really degraded. So the first thing we might need to do is some kind of physical chemical modification. So we're trying to get past this abiotic barrier that allows us to add species. The idea is that while we're here, the site may not be functioning well enough for the species to establish well. So we might need to deal with pollution. We might need to deal with structure. So you think back to that stream, it was super eroded. So we might need to add some rocks, or we might need to just change some different things about the physical kind of topography of the area. But once we get past that abiotic barrier and the site is working well enough that things can live there, that's when we can do biological modification, is what it says here. But basically we're going to introduce new things, and the most important thing usually is to add plants. And so you want to start with the dominant plant species and make sure they're starting to come back. Some things may come back on their own. If there is a seed bank in the soil, most of us don't think about it, but there are all these seeds. And if you hear Johnny Armstrong talk about his shortleaf pine restoration project, he also talks about the bud bank. And he's talking about these root systems that are underground that have buds. And once you get the site to a place where those plants can live again, they start sending up shoots. And so depending on how long your system has been degraded and how badly degraded it is, there may be parts of the plants living dormant underground that can come back very quickly. If not, then you're going to need to plant things, particularly whatever takes up most of the space in the ecosystem and starts to return that function. Once you start getting it vegetated, you may get birds bringing seeds in. You may start to restore some function. And then once you go through this biotic barrier, there may just be improved management. So if it's a fire-dependent ecosystem, we may need to make sure there is prescribed burning at some regular interval. We may need to continue to remove invasive species. But whatever it is, it may just need a little bit more help once a lot of the species are there and the abiotic environment is where we want it to be. So, considerations. You want to think about the speed of restoration you want, the cost that you're willing to accept, the reliability of the results, and the ability for the ecosystem to persist without additional effort. Examples might include the cost and availability of seeds. Sometimes it's hard to get seeds for certain native plants, so you may need to go collect those yourself. Should you be watering plants? Should you be fertilizing plants? How do you get rid of invasive species? How do you prepare the soil? All of these questions need to be answered before you can really get started. Other question is, what order and when should system components be put back together? Should we put one thing in before something else? If components are different trophic levels, it may be obvious. So like Obviously, you don't want to reintroduce an animal that eats plants if the plants it needs to eat aren't there yet. So those kinds of things need to come into consideration. For different species in a guild, it may not matter what order you do it in. You might need to think about genotypes. So ideally, you'll be able to get stock of plants from nearby so that you know that it has all the local adaptations for that area. There's also concerns about outbreeding depression and genetic swamping, which means you don't want to bring in some species from somewhere else. And if there's some of the native species or the native varieties still there, we don't want to swamp out their local adaptations with plants from somewhere else. You also don't want to deplete the local population, so you don't want to take them all out of one area so you can restore this particular place we're working on, only to need to restore somewhere else later. Monitoring, as I said before, is really important for telling you whether you've met your goals or not. It's often best to experimentally test different restoration methods. And this is called adaptive restoration. So it's a lot like adaptive management. In fact, it's exactly the same, except that instead of just managing, we're restoring. So the idea here is that we continually collect data. And then if something appears to be working, we might keep doing that. If it's not working, we might try another restoration strategy, but keep collecting data so we can compare the changes through time with one practice over another to help us make the best decisions. Most efforts focus on restoring plants because they make up most of the biomass, but there's others that argue we should focus on animals as well, and we'll talk a little bit about that. And the final considerations are that you may need stakeholder support. So it may help a lot to have the support of any groups of people that might be affected by this restoration project. And some stakeholders may want to help, and that may help you be more successful. So urban restoration is one kind of category of restoration. This is becoming more common because it enhances the quality of life for people that live in cities. And the benefits include improved air quality. We talked about the ecosystem services of having natural ecosystems. Some of them are psychological, and so we find that people are more stressed when they're in a more developed landscape, and they tend to have lower stress levels, better immune response, things like that, when they're exposed to more natural environments. And so restoration may be one way to help with that. There may be recreational value. It may just look better. Flood control, having plants to shade may help deal with heating and cooling costs. Some examples include like fixing up concrete culverts and canals, vacant lots, gravel pits, and adding a lot more plants that helps deal with the heat in the city because all that concrete and asphalt traps a ton of heat in the summer, making it warmer than the surrounding more rural landscape. And so that is also a reason for urban restoration. It also goes with the idea of reconciliation ecology, this idea that we can do conservation anywhere to improve ecosystem function and improve conservation for a variety of different species. And so this video that you'll watch next is kind of an example of one of these projects.